So here we are at the Unified State Laboratories of Public Health, and we're going to look at the pedestrian access ramp here. So let's start going into the form and filling it out. So first you will notice is the inspector. So that is where you can come and you can put your name. Next is the PIN or the project that you are working on. You can fill out that information. Next is the date. Put in today's date. Next is the access ID number, TSID number. Now this can be found in UPlan. Here is the link to the UPlan map. To find or request a new TSID number, follow the procedures outlined in the How to Find or Request an ADA Access TSID Number document found on the UDOT ADA Pedestrian Access webpage. Once in UPlan, use the search tool and type in ADA Access Map to find the correct map. To find a TSID number, simply zoom to the location you would like to find and click on the point to see the TSID number. If there isn't a point, click on the Edit button to add a point to this location, and then email adaramps@utah.gov letting them know of your request for a new TSID number. Next is the city, right in the city of where this ramp is located. Next is the county. Same thing, you can write in the county. And then we look at the primary street. What's the primary street of where we're at? Next we look at the crossing control. This says, is it signalized? Is it a stop or yield condition? Or is there none? In our particular case, we don't have a signal, we don't have a stop sign or a yield sign, so it is none. Next is the secondary street. I'll look to see if there's a secondary street here. Here we don't have one because we're at a mid-block crossing. And then crossing control, we don't have any there. So first off, we're going to come upon this ramp and we have to identify, is it a parallel ramp, perpendicular, combination, or an at-grade access? So to do that, we need to identify where our turning space is. And in looking at it, we have a nice flat spot here at the bottom of the ramp. And if this is the bottom of the ramp, then we have our one ramp to the right, to the front, and to the left. And so we can see, because our turning space is at the bottom, then it is a parallel ramp. The next question, does it serve multiple crosswalks? We only have one place to go when we cross the street, so it only serves one, so we put no. The access location, it asks, is it a corner or is it a mid-block? In this particular location, we are at a mid-block. Next, asks for the direction location of the ramp, the north, south, east, west. We're on the north side of the road. Next, on our C170 form is a sketch. We can draw a quick sketch of what the ramp looks like and how it relates to the road. Next item on our C170 form is the ramp. So we will look at the three ramps to measure the running slope, the cross slopes, and to see if the grade breaks are at the top and the bottom of the ramps. So we will start with the ramp off to the left.
.3% running slope.
And we have 5.3% running.
0.9% cross slope.
And 0.9% cross slope. And our grade breaks appear to be at the top and the bottom of the ramps.
The running slope for the center ramp is 3.7%.
So for the center ramp, we have a running slope of 3.7%.
And a cross slope of 0.5%.
And a cross slope of 0.5%. And for the right,
running slope of 7.2%.
we have a running slope of 7.2%.
Cross slope of 0.1%.
And a cross slope of 0.1%. So all of our running slopes are less than 8.3%, and all of our cross slopes are less than 2%, so we pass. Next, we move on to flares. In this particular location where we have a parallel ramp, we do not have any flares. So we will put NA on the form to indicate that we looked at this and we did not forget about it. Next is the turning space. We'll take the measurements of the turning space, the running slope, cross slope, the width, the depth, and we'll determine if it's constrained or unconstrained. So first off, we can see that there's no barriers around it, so it is unconstrained.
The running slope of the turning space is 1.7%.
So we have a running slope of 1.7%.
Cross slope of the turning space 0.1%.
And we have a cross slope of 0.1%.
The depth is 5 feet 9 inches.
The depth is 5 feet 9 inches, which is greater than 4, so we pass there.
It's 8 feet.
8 feet for the width. And then you check to make sure that there aren't any grade breaks, and I do not see any grade breaks within the turning space, so we pass there. Next is the accurate access. We do not have an accurate access at this location, so we'll put NA on the form. The next item is the cut-through island. Once again, we do not have a cut-through island, so we'll put NA. Next, we'll check the clear space of this ramp. The clear space goes from the flow line of the curb and gutter, and it extends out 4 feet, and it is the width of the curb cut. So we will take the running slope, the cross slope, and we'll make sure that the clear space is within the crosswalk entirely and outside the parallel vehicle travel lane. So first off, we can verify the clear space is within the crosswalk, so we're good there. And we'll take our measurements. So we'll take our running slope of the clear space. And here we have the gutter, and we also have the road. And we have our split in between the two, so we'll want to take 2 measurements to see which one is higher and which one controls. So first we'll take the measurement of the gutter.
And it's 1.3%.
And we have 1.3%. And then for the road itself,
0.7%.
is 0.7. So here we have 2 different values. We have the 1.3, and then we have a grade break, and 0.7. So which one do we put? We put the higher, so we'll put 1.3 as the running slope. So next on our item is the cross slope. So we'll measure the cross slope of the clear space. So we'll measure once in the gutter here, and we have 0.1, and then we'll also measure in the road, and we have 0.4. So which one do we put? 0.1 or 0.4? We'll put the higher of the 2. So we'll put 0.4. And where this is a mid-block crossing, we have the option of going up to the road grade. And so we can take a measurement of the road grade to see what our maximum value is. And our road grade comes in as 0.4. So what do we do in the instance where we're less than 2%? We can go up to the 2%. Our 0.4 is less than 2%, so we pass. And lastly, on the clear space, we check to see the vertical discontinuities. So the most common place you'll see a vertical discontinuity is your clear space is at the start from where you transition from your top back curb to your gutter, or from where the gutter meets the asphalt. We have a small lip between the top back curb and the gutter at a 3/8 of an inch. That 3/8 of an inch falls within that 1/4 of an inch to a 1/2 inch. So we need to have a surface that is beveled at 2 to 1. And looking here, our surface is beveled at 2 to 1, so we're okay. The next location we want to check is between our gutter and the road. So let's see if there's a vertical discontinuity there. So there we also have a 3/8 of an inch, but we're also beveled at a 2 to 1 in this particular location, so we pass there. Next on our C170 is the detectable warning surface. So there are a few things that we check here. The type, the color, the curb cut width, the depth of the detectable warning surface, if it's within 2 inches of the top back of curb or 2 inches of the base cut, if there are any gaps in the panels, and if it is directional or not. So first we check the type of the detectable warning surface. Here we have a polymer surface, so we'll circle polymer. Next we look to see if the color contrasts with the surrounding environment. So the yellow contrasts with the concrete, and so we will circle yes. Next we have the curb cut width. We just measured that, and that was 8 feet. So we are greater than the 4 feet because we only serve one direction. So we pass there and we can put a little note of 8 feet wide. Next is the detectable warning surface depth. That is 2 feet. We've verified it's 2 feet. Next, we make sure that we have 2 inches from the detectable warning surface to the top back of curb, and our detectable warning surface has to be within 2 inches of the base of the curb cut. So first, within 2 inches of the top back of curb.
Here we have 4 inches.
Here we have 4 inches, so we are greater than 2, so we're just a little bit too far away. We should move our detectable warning surface a couple inches, or prefer all the way to the base of the curb cut.
Here we are about 1.5 inches from the base of the curb cut. So
And here we're 1.5 inches away from the curb cut from where the detectable warning surface starts. For that aspect, we're okay. We're just out of compliance where the detectable warning surface is in relation to where the top back of curb is. We just need to move that in a couple of inches to be within compliance. Yeah, the same thing on the other side. We're under 2 inches, but we're still 4 inches away from the top back of curb. So next we check to see if there are any gaps, and we can see that there's no gaps between the panels. We're under 2 inches, and so we will circle yes. And this is not a directional case, so we put NA there. Next is the pedestrian access route width and the cross slope of that. So we'll look at our pedestrian access route. Where is our pedestrian access route? Well, we come to our ramp, we come to our turning space, and then we have the option. We can either turn and we can go that way, or we can turn and we can go that way to straight, or we can turn and we can go that way. So we have 3 different pedestrian access routes. So we will measure the cross slope at each of those routes and the width to make sure that we have a minimum of 4 feet. So first, for the width off to the left, so we can see that we have quite a bit of width here,
16 feet.
and we have 16 feet and a cross slope of 1.2%. So we meet the requirements there. Next, we will take these measurements at the location in front of us. So we have a cross slope of 0.8%.
9 feet.
And a width of 9 feet. And lastly, off to the right, we have 16 feet there and a cross slope
1.7%.
1.7%. So we are good. Next on our item is our crosswalk. We look at our crosswalk and see if it is marked or an unmarked crosswalk. Here we have the striping that leads us out into the road. So we have a marked crosswalk, and we'll take the running slope of the cross slope of this crosswalk. Here we have our running slope
2.9%.
of 2.9%. We are less than 5%, so we're okay there. And we have our cross slope of 0.3%. And we're under 2%, so we're okay there. And once again, it is a mid-block, so our cross slope can be up to the road grade. And then lastly, we have our pedestrian push button. At this particular location, we do not have a push button, so we will put NA on our form there. And then lastly, there's suggested work to meet UDOT to meet standard. You can go through, check the appropriate boxes of what can happen or what can be done. Next is the certified UDOT inspector and the contractor. You will write your names. And then when you are done, remember to upload your file to ProjectWise, send the form into adaramps@utah.gov, and also copy the FHWA area engineer when you send in the form. At the end of the C170 form is a section for the C171 technical and feasibility form. You only need to fill out this section of the form if you have a technical and feasibility. You may have a technical and feasibility if any of the sections are out of compliance. On overlay projects where we aren't reconstructing the road, we still require a technical and feasibility on crosswalks if applicable. If the sidewalk is part of the scope of the project, then the sidewalk needs to meet standard. If the sidewalk is outside the scope of the project and doesn't meet standard, Then we transition the first square of the sidewalk to tie the pedestrian access to the sidewalk, and we don't require technical infeasibility. The first question asks you to identify the reasons you have a technical infeasibility. Please check all of the boxes that apply. The next question asks if right-of-way is being obtained on the project. If right-of-way is being obtained on the project, then right-of-way will need to be obtained for the pedestrian access as well. If right-of-way is not being obtained, then right-of-way could be considered a technical infeasibility. Next, please attach a cost estimate to build the access to standards. Next, list the elements that are not in compliance, as well as any remarks. Lastly, obtain the required signatures. File the form in ProjectWise, and send the form to adaramps@utah.gov, as well as the FHWA area engineer.